This is Mr. Jackson reaching out to you from Southeastern, live from Lakeland, Florida. So I wanted to go ahead and go over some more information about the concepts that we've been discussing. Yesterday we talked about the motherboard, looking at the computer chip. You guys had some good things on your computer chip and learning some information about that, along with your circuit board. And then also we discussed a little bit of the CPU, which is your central processing unit. All right. And it helps your computer perform different functions based on the different processors. And then we talked about multi-core CPUs and a CPU that contains processing components for more than one single processor. So we're going to continue on with that information and discuss clock speed. So clock speed is basically how fast your computer is able to process instructions, right? So whenever we're moving the mouse on the screen or what have you, is sending a direct signal through our CPU to go ahead and complete a certain task. So how fast that task actually works is a part of our clock speed. So it's rated in megahertz and then also gigahertz. The other factors affected the speed of your PC is your GPU speed or your graphics processing. So the more graphics that we use, that can slow down our computer. More cache memory results in faster processing. So the more memory that we have available on our computers for cache, it actually allows our computers to work a little bit faster. So RAM is actually the acronym for RAM is Random Access Memory. So memory are locations the computer uses to store data temporarily. And so the random access memory is the main memory for the computer. All right, so this is the memory that the computer can access very quickly. And there are memory chips that are embedded in the different modules to go ahead and work with that. Also, the capacity is measured in bytes. We talked about bytes yesterday as a part of our bits, right? Bytes are a collection of bits, and that is how data is stored within our computer. And then there are various types of speeds that are available for your computer. All right, and you see how the RAM actually looks a little bit different for a desktop computer and then for a notebook computer. It looks a little bit different. So the other types of memories are a register, which is a high-speed memory built into a CPU. Then there's a read-only memory, ROM. So it's non-volatile chips used to permanently store data or programs. So remember that our RAM is kind of like temporary, okay? So this is permanent data that will always be on the computer. Then we have flash memory, non-volatile chips used for storage. And they're used in BIOS, the instructions that run when a computer boots up. That's a part of your flash memory. So whenever your computer is going through that boot up stage, it is using flash memory. Then it's also embedded into devices and storage media. So expansion slots and expansion cards. So I talked to you guys a little bit about that yesterday. Within our computers, we have expansion slots. So there are locations on our motherboards where we can insert a card into them, and then that card to be used for different things. Like if we have like a dual monitors, or we want to include a different graphics card, so stuff like that. And these are the expansion cards and kind of what they look like, and they'll have that little connector into them. Like say for instance we want to include a different interface that would have a Ethernet cable. With your Ethernet cable, that's what you use for internet. This is another mini expansion card, which is a little bit smaller. All right, so for a wireless network, if we wanted wireless internet on our desktop computer, we would go ahead and include that. And then this is a USB adapter that is used for wireless networking as well. So moving on from there, we're going to talk about buses. So buses is an electronic path over which data can travel. All right. And bandwidth is the amount of data that can be transferred by the bus in a given amount of time. And then finally, throughput, the amount of data that is actually transferred. So we have a bus, which is basically an electronic path. We have our bandwidth, which is the amount of data that's transferred through it. And you can think of it like a railway. And then our throughput is the amount of data that is actually transferred. Then you can always use an expansion bus used to connect peripheral devices. So if you have a device that you need to connect to it, then it will go through that expansion bus, which that kind of like trainway to go ahead and connect different information. So that is our expansion bus. A universal bus is used through a USB. So if you have a USB cable that maybe connects, like say for instance, you got an external hard drive. So that bus cable is your universal USB cable to go ahead and connect it. So that is a way. So this is buses and expansion slots. So this kind of shows a little bit of a different idea of how it actually works. All right. So where it goes from the CPU to the actual item that it's connected to. So this is an example of a USB bus. It has its chipsets that are located in there. All right. And then it connects to your CPU chip. And you have buses that go to different memory slots, and those all connect to your RAM. So talking about ports and connectors, so a port connector is located on the exterior of the system unit to which external devices can be connected. Desktop computers typically can have more than one mobile ports that are associated with it, so that way you can include different things in there. You know, you've seen the multiple USB ports either on your laptop or on your desktop. Most devices have USB ports, like I've already said. USB-C is the newest type of USB port. So things with that is that it's faster. Cable ends are interchangeable. So you know you can kind of flip off the top and then change it with something else, and then you can move it. So this is an example. This is the new USB. Oh, let me go back. This is new USB-C type of port. All right. This is a USB-A, which is kind of the existing like what everybody uses right now. We have the HDMI monitor port. Then this is our network RG45 or Ethernet cable. Then we have your aux cable, right? A lot of people use this for audio. And then this is an example of how they look on the back of different computers. All right, so you got your flash memory card slot. Remember, this is kind of like some things that people use in their cameras, where they have the flash card that they actually take out and then they can place into their computer to, you know, give different pictures. So that kind of flash memory card. You got your USB ports, your network port, which is that where your Ethernet cable goes into, and then your audio port. That's where your aux cord or your audio cord can go in through. So a lot of different things there. So how does the CPU work? All right. So the topics that we're going to cover with that is typically the CPU components, the system clock, and the machine cycle. The transistor is basically a device made of a semiconductor material that controls the flow of electrons inside the chip. The key element of a CPU. So typical components in a CPU core are the arithmetic logic unit, or ALU, and that performs integer arithmetic and logical operations. So math operations, all right? So that is something that is componented into it. Your floating point unit, which is performs decimal arithmetic functions. Your control unit controls the CPU activities. Your prefetch unit retrieves data or instructions by the time they are needed. And then your decode unit translates instructions into a form that the control unit can understand. Then finally, your bus interface unit allows the core to communicate with the CPU units. So this is a lot of detailed stuff, right? So there are all functions. So your math, arithmetic, or logical functions that your computer goes through. It sends those functions out so that way it can communicate back and forth between the CPU and whatever item is connected to it. Other items within your central processing unit to go ahead and translate information back and forth. So here are some examples of how these components are used. So you have your control unit is in the charge of the entire process, making sure that everything happens at the right time. It instructs the ALU and FPU and registers to do what it needs to do. So based on the instructions, so that is your control unit. All right. Then from there we have our arithmetic logic performs those math functions. All right, for the computer. Your prefetch unit requests instructions and data from the cache memory. All right, and your RAM to make sure that it's in the proper order for processing. Then we have our decode unit takes instructions from that prefetch and then it kind of translates it out. We have our registers, which holds the results of processing. Then finally, we have the bus interface unit, the place where data and instructions enter and leave the core. Then we have our internal cache memory. All right, so and then it all comes from an input and then an output. So our system clock and machine cycle. So your system clock basically is a timing mechanism within a computer that synchronizes its operations. So during each clock tick, the CPU executes one or more basic instructions. So the machine cycle, whenever the CPU processes a single basic instructions. So through our steps here, we have the step one. The next instruction is fetch from the RAM. All right, so that's when it's actually retrieved from the RAM. The second step is that the instructions are decoded into the ALU FPU system. So to decode it. Then number three is that it executes, so the instructions are carried out. And then the last step for step number